Hello and welcome to another video. Today I'm going to be going over another Raspberry Pi project. This one was from a Udemy course that I took under Peter Delmaris. First I'm going to go ahead and go over the Raspberry Pi hardware setup. I just have a Raspberry Pi 2 here with a Wi-Fi dongle connected to a DH22 temperature and humidity sensor. This is the pin. It's just power, ground, and pin set up on a mini breadboard. Alright. So basically what we're doing in this setup is we have a Raspberry Pi connected to a sensor that's constantly taking the temperature and humidity of my apartment, and I'm taking that data and storing it in a light database, and then we're putting that out to a web page so we can view it. So here's the GitHub. I'll write a little README so you can get a little bit of information about the different stack that I'm using. Basically, we're using Flask, the Python micro framework for our web server. We're using uWSGI as the server for Flask, an Nginx lightweight web server, Skeleton for the UI. We're using a DH22 sensor, SQLite for the database to store the sensor. We're using a cronjob to store the sensor data every so many minutes. Right now I have it going every half hour. We also have Google Chart API on the web page, as well as a link to Plotly. And I'll show you what all this looks like. So first we're going to go through the code. This is the main Python script. Basically this serves up the different data to both web pages. We have two main web pages. This first one is going to just display the current temperature, and we're using the Adafruit DHT library, which is getting the information from the sensor on a specific pin and storing those two humidity and temperature variables. If the sensor isn't found, then we'll display that in a web page. Otherwise, we're going to have this regular page with just the current variables. Here's the second page, our environment. This is the data that we're getting from the database, and we're just displaying it on the web page. We do some time zone conversion so we can get it from your actual operating system through the browser, so all the data is actually displayed in your current time. And here's the database stuff right here. We're connecting from the database that we create, SQLite. And then here's the functions to go to Plotly. And we'll see what that all looks like in just a second. So here's the HTML code. This is just the very generic using skeleton CSS for the current temperature, and this is what that page looks like. We're connected to the Pi. So the current temperature is 78 degrees Fahrenheit in my apartment with a humidity of 41%, and this page just refreshes every 10 seconds, and it has a link to the historic data, which we can go ahead and look at. First, let's look through the code. This is a little bit different because we have a date range selector. So we can do a date picker between whatever year, month, day, and hour to and from, and we'll have a submit button. We'll differently have 3-hour, 6-hour, 12-hour, and 24-hour ranges as radio buttons. So we'll be able to see within the last 24 hours. If we just wanted to see a quick view of that, we can. And we'll have two different tables as well as two different graphs on that main page, so we can go ahead and look at it. This is what it looks like. So we'll have a from date to date where we can select using this date picker plugin and submit that to find out different time ranges. We can also select these radio buttons to get the last 3 hours, 6 hours, 12 hours, or 24 hours. This current button actually just brings us back to this regular page right here. It's currently reloading every 10 seconds. And if you hit the historic button on this page, that is what brings us to this page. So we can navigate back and forth between the two. So here is the temperatures, and we have this in a scrolling format so you can see however much data is needed, however much we have displayed within the range. I'm currently doing everything from today up until today's date. And here's the humidity as well. And here's the Google Charts on the side for both the humidity and the temperature. So you can kind of see throughout the day where is it getting really cold and where is it getting a little bit warmer. Well, you can definitely see that it gets a little bit warmer, especially when people are in the room that the lab is actually in, the Raspberry Pi and sensor are in my workspace, and that's where I come to do a lot of my projects and homework and stuff like that. So whenever I'm in here, I can definitely see that the temperature increases a little bit. And that's basically it. So it's a really neat project. Raspberry Pi, really low cost, $35. The Wi-Fi dongle is basically comes for free if you buy the Raspberry Pi 3 that comes with both Bluetooth and Wi-Fi. The jumper cables, breadboard, resistors, and sensor you can probably all get less than $15 combined. And then the software, you can just check out the GitHub. I also recommend looking into the Udemy course that I took, Full Stack Raspberry Pi. Very interesting. Learned a lot about the Python virtual environments, as well as Flask, uWSGI, Nginx, Skeleton, SQLite, and Google Chart API with Plotly. Just going to go ahead and give a little bit more tour. This is the current temperature, and here's the historic page that'll take us back. It was being a little bit sluggish earlier, so I went ahead and restarted the Pi. Now it's acting a lot faster. So we can go between these two with the current and the historic, and we can click the Plotly link and we'll be able to see our plot through this. We can see right here the humidity percentage and the temperature in Fahrenheit across the different days and the different hours we have. So it's really cool. Feel free to check out the code on GitHub. It's a really interesting project just to be able to have something in your apartment or your home and be able to check your temperature and see if throughout the day when it gets hotter, or maybe if your AC dies, it's a good thing to be able to verify and check. So feel free to look through it and have good use of your data. Alright, thank you for watching. Till next time.